Hey, Internet. Well, today we're going to do something a little bit different. I'm going to just kind of go through some of the early bits of the code we have here for the cat chasing robot that we saw in the previous video. This is an Arduino, and we're going to first of all just kind of look through a little bit of what we've currently got set up, and then talk a little bit about some of the problems and things we'll be aiming at for the next versions. We've got a few definitions here. We've defined what the infrared keypad values are, so that when we pick up the infrared keypad inputs, we've defined them as easy to read numbers. Some preset values for some of the current behaviors. These ones here represent the various ways that the heartbeat reacts to its different speeds and to its different dimness levels, so we can really fine tune the way the LED heartbeat works. These ones here define some of the output pins used for the LED, the input and the receiver, and the matrix. And these values here define the different moods and the different faces that can be seen on the front display. Um, Going down, we have a few of the other constants already defined. These are for the ultrasonic echo, the rot comp value, the roll delay, all these servo things here. These really are used only when the servo class was being used. As I mentioned earlier, the servo class clashes with the LED on pin 9, so I can't use the servo class. I'm going to have to write my own servo routine, but that'll come later. Um, this array here, this is how the different expressions on the display are stored. Each one of these is 8 bytes in an array, and each face or each display that we have rotates between 3 different images. So we have 3 groups of bytes, and then we have currently 7 displays currently set up. The ultrasonic distance sensor, initiate that, set up the IR sensor. Um, so here's where we define the prototype structures, and this is basically copied right out of the example. And they've named them PT1, 2, 3, 4, 5, and 6, just as I have. Um, and I think that moving forward, I'm going to try setting this up into a prototype thread array, so we can create an array of threads. And I think that'll make it a little more graceful. The state is basically the state of the robot. There aren't too many values in there right now. Range array holds our distance in centimeters for how far away each ping is across a 180-degree sweep of the servo. Heart rate indicates its current heart rate. Its range is a current range at whatever the view angle is. So view angle and range kind of go together to populate the value of range array. This it just basically sets up the state value so that when it powers on, it goes straight into eyes with a sleep heart rate. Here we in the setup, we're setting up our pin mode. Probably shouldn't use a magic value. I believe that's our LED. But anyway, setting up the serial port output, the infrared input, and you see I've commented out the servo because as soon as we attach the servo, it disables the LED. That servo's not doing anything because the servo's not attached. It'll delay, and then here's where the threads are initialized. This is where I think that an array would be a lot more graceful here. So I could basically run all these things through an array, do all the initializations all in one loop, basically. And down here as well, in the loop itself, the loop basically just calls each one of the threads. These could also be, easily set up to be as an array. Uh, so here's our first thread. So the idea of a proto thread is that there's a small amount of code that comes up at the top. This initializes the thread. This is what runs when it's initialized. And then there's a PT begin, and then everything in between the PT begin and the PT end down here. This is the code that's executed in between the loop. Now we have the while one, which is surrounding the entire thing. And in almost all situations, I think you'd probably have the while true or while one inside, completely inside the PT begin and PT end. But this proto thread here, what it's doing is that it's constantly monitoring whatever the state view angle is. And at any time, the next angle, which is the angle that is the servo currently pointing to, differs, not equal, to the view angle, then it's going to trigger the rest of the code here, which turns the servo into the angle that matches state view angle. So basically, this runs only when next angle and view angle are the same. It moves the servo to match, and then goes back and waits until the servo is being told to go to a different angle when it's currently at. Now this all is going to have to go. This actually worked fairly well. The servo cliff, the servo weight, and the servo delay, all of these actually help to make the servo appear a lot more dampened. So instead of snapping from one end to the other, it changes rates during its sweep using the servo weight and the servo delay. So it worked really well, but it also had a bit of a small bug that it couldn't take two server requests at the same time. Code had a bug, so I'm kind of glad to get rid of it, but I've got a pretty good solution in my head. I just need to get it down here. This is the Protothread that runs the heartbeat. So basically, whatever speed the heart rate is going to be running at delays how long it waits between dimming heartbeat. So that's the heart rate here. So in this loop, we're setting up the millis, finding out the heart time, and then waiting until the millis is greater than the heart time plus the heart rate. So, and then it diminishes or dims down the heart level light. So basically it makes the LED dimmer until it hits its lowest point, and which is a heart drop, and then restarts the loop again. Um, this is a behavior thread. This is using a proto thread as well. I'll be setting up the behaviors in the robot as basically the threads that will monitor the different sensors and do the outputting of the different states. So in this case here, we're waiting until the last range off of the ultrasonic sensor has achieved a certain amount of a limit called the range check, multiplied it here by the alert window. And at any time that the range on the ultrasonic sensor changes by a significant amount, then it triggers the alert, sets the alert mode, hits the wait until. The proto thread allows it to go through and run the rest of the threads. So as soon as it hits the alert mood sets and the medium heart rate is set, and it hits this PT wait until, the other threads that update the heart rate and mood screen, the front display, will be allowed to continue on. It waits until the alert time and then goes and turns them off, puts the mood back to its ping mood. This proto thread is updates the state array. So basically, anytime I think this runs every 60 milliseconds is the way we have it set now, which is really the shortest we should do. I may stretch this out to 80 or 100 milliseconds because I do get a lot of kind of noise. I think I'm seeing the output signal trigger the input signal. So we'll make play with the range delay here. But what's happening basically is in this thread, there's a constant ping off the ultrasonic sensor. Basically, we're taking the average of two consecutive pings and then updating that into the range state array. Now, this is about as least graceful way as there is to take two things and then find the average, literally taking a second one into a different variable and then dividing them by two. So this is obviously going to be updated. So we'll have a much cleaner way of updating the range array. The mood face array or the set display, that's just taking that array of chars we have up here that run the mood face, and it's cycling through each one of these three based on whatever current mood it is. We have 7 moods, we have 3 frames per mood, and 16 bytes per display. Basically output the first mood, increase the index by 1 if the index is 3 and make it back to 0. So we get indexes 0, 1, 2, and then repeats and constantly displays whatever 3 frames are set by the state mood variable. This monitors the infrared input. This is the keypad. Right now we only have 2 buttons programmed, but this is good for setting up predefined programs or states. and a couple other just small routines. I did the math. These again, part of the servo class we're not going to be using anymore. And this bit of code is straight from the Keyestudio website that runs the display. So this is taking the chars and sending it out to the matrix display on the front. So a lot of things to happen. You want to make the threads uh, set up in an array and a lot easier to read and to call that way. I also want to set up another value in the state and for each mood so that each proto thread can have a suppress. At this point, basically have autonomic things, the heart rate, the range sensor, the servo, all reacting to things, but we want to be able to suppress things. Specifically, we want to be able to suppress a movement, which we haven't even got the wheels activated, but at some point we're going to activate the wheels, and we want to be able to suppress that movement. And there's other things we want to be able to suppress as well, and essentially turn off a thread, overriding it temporarily based on the mood, the setting of the state. So that will be coming in a new version of how the proto threads are set up, a new version of the state. We have to write a new servo handling routine because the servo class clashes with our LED on pin 9. And then maybe even start doing some testing on the motors. For now, that is all we have so far. But once we've got that servo operational, turning the head or turning the ultrasonic sensor, I'll cook up another video and we'll have a look and see what it looks like. Until then, thanks for watching.